All right, good morning, good afternoon, good evening, everyone. Welcome to a bright new year with 2023 and January 23 office hours for Layer7. And with that, I'm going to turn it over to Gary.
Thanks, Bill, and thanks everyone for joining. Happy New Year. So today we're going to be doing more of a deep dive of the Gateway Helm chart. So I'm going to do a quick recap now of the previous sessions. So this is session 3. In session 1, we did running the container gateway with Docker, so Docker desktop or just Docker. We went through using Docker run, setting up a Docker compose file, and we also went and deployed Kind, which is a local development environment for Kubernetes. We used a minimal gateway configuration example, all written by hand, and we deployed the gateway using kubectl. So in session 2, we introduced Helm, and we went through creating a very basic sort of hello world Helm chart, and we then went through a basic install, upgrade, uninstall, along with some very basic configurations of the gateway Helm chart. So today we're going to be going a bit more in depth into what we can do with the gateway Helm chart. This is not going to be an exhaustive list of everything that you can do with the gateway Helm chart. So if there are specific sort of configuration areas or questions that you have, then please feel free to interject throughout. And I'll try and answer them during the session with examples, hopefully. Or we can look to schedule follow-ups in the future where we can spend more time on specific areas that you'd like some more information on. So I'm going to sort of break this down into two main areas. So gateway configuration, which includes container level. And so that's file system, custom modular assertions, custom config files, additional scripts that you want to run. And that kind of represents what you might be doing from an appliance gateway perspective. And one of the most frequent questions that we get from customers is, how do I take what I have on my appliance gateway and make that available on my container gateway? So we'll go through configuration of some of that. The demonstration today is going to be centered around a database-backed gateway. The majority of this is also possible with the ephemeral gateway, but there are some limitations associated with that. And we'll be working on additional options in the future that will allow you to have more advanced configuration for ephemeral gateways as well. So application level, from a gateway configuration perspective, that includes things like APIs and services, and other gateway configuration items like cluster-wide properties, listen port configuration, JDBC connections, and so on. Another question that we get quite often is, how do I configure networking with my container gateway? So I'll go down, so I'll introduce a couple of options, and I'll also introduce the sort of concept around PM Tagger, which works with a separate management service. We'll then answer the question of ingress versus load balancer. When should you choose which one of those? It's pretty much going to come down to what is sort of mandated within your own organization, and I guess as well, it'll sort of be a choice. But I'll go through the pros and cons of both approaches. We'll then talk a bit about gateway management. I'll kind of cover this here, and then I'll show you using PM Tagger, and once we've actually deployed the demo, gateway management with Policy Manager. I've mentioned bundles there because bundles with the ephemeral gateway and the gateway Helm chart is kind of the only way to update the API gateway. So that's going to require a gateway restart or a cascading restart or an upgrade of your deployment for the ephemeral, and that's currently the only way to sort of do that. I'll then cover at a high level some additional features that we have in the gateway Helm chart. These are mostly things that Kubernetes gives us for free. So we allow you to, or we enable you to configure those in the Helm chart configuration. And finally, we'll head into a demo. So I'm probably going to go through maybe 15 minutes or hopefully less than 15 minutes of slides, and then we'll go into a demo environment. I'll also show you where you can find a very similar demo environment up on the community GitHub site. So if you wanted to take a look at some of the configuration that we're using later on, then you'll be able to head over there, and most or all of the configuration is available to get started with there. So just to sort of reset some of the context, the gateway Helm chart, we're going to go through today creating some configuration. We'll create some secrets. We'll also create and configure an InitContainer. We're going to reference all of the things that we create in our values.yaml file. We won't be including any usernames or passwords in our values.yaml file. Through Helm install, we're then going to take that values.yaml file, we'll pass it into a set of templates, and that'll generate some Kubernetes valid manifests, which represents a desired state. And Kubernetes will turn that into reality by instantiating a gateway deployment, by standing up services, and connecting to optionally our database. So here's a breakdown of the configuration for our init container. Well, I guess it's kind of all blue, but we have container level configuration. So with that, we have modular assertions, custom assertions, and scripts. I'll show you on the init container. On the init container examples, there's a breakdown of exactly where each file goes, or where each type of file goes. It's a very easy structure to follow. It works with the flag and the gateway Helm chart, so I'll show you how to enable that, as well as how to build an init container that you can use in this context. So previously, before we had this level of support for init containers, we kind of required that you create a derived image of the container gateway. And while that's still an approach that you can take, it means that you have to target the gateway at a specific version, and you have to maintain that, throughout gateway upgrades and so on. Whereas using an init container, you maintain the init container, and all you're doing is pointing at a different gateway base image, which allows you to upgrade a lot more seamlessly than if you were to maintain your own gateway base image. So we'll go through folders of modular assertions, custom assertions, and those scripts, and I'll sort of show you where all of that fits into the init container. The second level of configuration is app level configuration. So that includes things, so like I mentioned, JDBC connections, trusted certificates, listen ports, etc., as well as APIs and services. So there's a couple of ways that you can configure those. You can use init containers as well. There's a section in the configuration for bundles. So you can have multiple folders with different bundles that you want to include. Those are going to get written directly into the Bootstrap folder of the gateway. So you can do that. Probably the most common use case is going to be RESTman, and in the future that would be GraphMan. So if you have existing pipelines for your appliance gateways, you're going to have a RESTman endpoint or a GraphMan endpoint in the future that you're going to be able to interact with and continue on with any sort of pipeline that you may have created in the past. You can also configure some of this in the Helm chart. This is really useful for things like cluster-wide properties, which may be different between different deployments of your gateways, as well as things like listen port configuration, which I'll show you as well. Are there any questions on the structure before I move on? Okay. So init containers are basically containers that run before application containers run in a deployment. So in order for the application, in our case, that's going to be gateway to start, the init container must start, it must exit 0, so run to completion, and that must be successful before the actual gateway can start. Something that we take advantage of with init containers in the context that we'll be using them today, and in the context that we recommend using them, is the fact that we can have shared volumes. So we can take a file system from an init container, and we can copy that onto a shared directory that the gateway can use later on in the process. You can also have multiple init containers defined. So it's just an array of additional containers that you can add. And yeah, so those will start up, they'll run, they'll copy files to a location for us, and then the gateway will start up thereafter, and it'll take the files that have been copied to that shared location and move them into the correct place. So a quick one on container networking. So the demo that we'll be going through today has this configuration or this setup enabled. So we've just got one cluster. But we have an ingress controller. We create an ingress resource, and that points to, we have an endpoint configured for that, which is office hours ssg.brcmlabs.com. That's going to route to the standard traffic service, which is going to be of type cluster IP in the demo today, and that's going to route to the gateway on a specific port. Now, for this model, basically you can have additional ports from inside your own network. So if you had, potentially like an FTP endpoint, or some other protocol that you wanted to expose internally but not externally, then you could have that model configured there. So any additional ports that you want to expose internally, you can access those directly in whichever protocol you want to, and that's going to go directly into your gateway cluster, and that'll be load balanced as expected by this traffic service here. For things like policy manager access, though, you don't necessarily want to have policy manager accessible from the outside world. So through this endpoint, through this endpoint, we have no policy manager access whatsoever. So no access from the outside world to policy manager. And you could go further and restrict things like RESTman with additional configuration to restrict all management to a specific port. So this is kind of where PM Tagger comes into effect. So the gateway for Policy Manager requires a stateful connection to a single node. In the appliance world, that's really easy because each appliance has its own IP address, so you can connect to that directly. Whereas in Kubernetes, we have a single interface to do that, and we're not going to typically connect into a specific gateway pod. We're going to go through a service. So we have a management service that can be enabled in the gateway Helm chart. That's going to give us an internal load balancer that can also be configured to be cluster IP, node port, or anything that you'd like. And PM Tagger is basically going to go to the gateway deployment. It's going to select one of the gateways, and it's going to add an additional label to it that will allow this management service to route to it. So it'll basically add one gateway to the management services load balancing pool. So you have one gateway connected to that always. If the management gateway goes down, then PM Tagger will simply select a new gateway as the management leader. So the benefit of going through the ingress controller route, ingress controller route, is the fact that you have one layer 4 ingress point into your Kubernetes cluster. So this represents a shared ingress controller. So this could be serving the gateway, it could also be serving other applications within your Kubernetes cluster. And it's all coming in through a single ingress point. The alternative is having the traffic service on the gateway, so of type load balancer, and that's going to have a layer 4 address for each of your gateway deployments, which may not be as desirable. In a cloud environment, you're going to be paying for each of those public IP addresses, and so that's going to increase both the number of ingress points that you have into your Kubernetes cluster, as well as the cost associated with managing your Kubernetes cluster. So in a lot of contexts, these layer 4 addresses are going to be internal only anyway. So whether you want to use an ingress controller or you want to use an L4 address directly is going to be much down to the way that your Kubernetes cluster is configured within your organization. So I guess the main thing is that you have the option of either using an ingress controller or going through a load balancer directly to your gateway clusters. So I've included a link here on the top right to some general updates that we had with 3.0.2. This kind of covers most of those. It also covers updates from 3.0.0. But basically, as I mentioned, there's a lot of stuff that Kubernetes gives us for free, like autoscaling. So we have autoscaling configuration that you can use. We'll be making use of that today in our demo. You can also do things like add custom health checks. You can have topology spread constraints, tolerations, and affinity. All of these kind of pertain to the way that gateway nodes might be placed within your Kubernetes cluster. So all of that's configurable. We won't go into much detail, sort of talking about those for now. And you also have access to pod security context and container security context. And as mentioned, so gateway config that might be quite useful to set per deployment, like cluster-wide properties and listen port configuration, can also be configured directly in the gateway Helm chart. And we'll take a look at that in the demonstration. So if there aren't any questions, I can head directly into the demonstration. Okay, so the majority of the example that I'll be going through today, related to the init container and related to some of the additional files that we'll be looking at and creating, can be found here. So this is referenced in the official Gateway Helm chart. So you can just come across to this link here, and it'll take you through to the community site with all of these examples. So basically, there's two examples. We have a way to sort of get up and running with this. So if you just want to install this in one of your dev clusters to take a look at it, then you can absolutely do that. There's a make file to install the simple example and a make file to install the dynamic example. So you can check out exactly what's happening in those, along with some additional resources that you'll need to add, like the gateway license and so on. The file folder structure that I kind of touched on earlier, we'll see that in the demonstration, but basically the shared volume is going to be on a path called opt-docker custom. That'll be shared on the gateway container image. That's going to have a folder called config, and that'll include bundles, custom assertions, modular assertions, and any scripts that we want to have. So this just has a breakdown of the way that those different things are run. There are also some additional config map or secret mounts. These are things that you can configure in the Gateway Helm chart, and I'll show you kind of where this where this becomes really useful in the container gateway. Being able to take a file, something like something that you wouldn't normally change and something that we don't actually expose in the Gateway Helm chart, like ssg.security, something that you probably wouldn't need to change in most cases. But let's say that you did, and you didn't have a way to do that. You can create that file as a config map or a secret, and you can mount that directly to a specific path on the container gateway as part of your configuration. So I'll quickly go through what we're going to be doing for this demonstration today. So the first thing we'll do is build an init container, and we'll push that into my private registry. We'll then create some resources using Customize. Customize is built into kubectl. There's also a separate Customize binary that you can download if you'd like to do it that way. But using kubectl is going to be the easiest way. So we'll go through the configuration that we have in there. We'll then deploy the Gateway Helm chart. Before we do that, we'll take a look at the configuration that we have. And then I'll show you the gateway logs. We'll take a look at those, and we'll see that our init container is doing some stuff when the gateway starts up. And finally, we'll check that everything is working by going to our Hello World endpoint. We'll also sign it to Policy Manager, and I'll show you the logs from our PM tagger as well. So we'll see the correct gateway getting selected or sort of added into the load balancing pool, and we'll connect to it via Policy Manager and take a look at what's inside there. So for our init container, we've got that config folder, and we've got a bundle. So the script on the gateway for Bootstrap is going to iterate over this folder for bundles. So you can have that in whichever structure you'd like to have. We've just got a simple Hello World bundle, which is just a RESTman bundle, and that's going to give us a Hello World endpoint that we'll sort of access later on. We've also got a custom assertion in here. So there's the traffic logger sample custom assertion.jar that's in there. We have a modular assertion, so we've got the gateway GraphQL assertion, just as an AAR. And we've also got a really important script that we want to run when the gateway container comes up. So this will get run. This will get run after the init container. The init container is just going to copy this to the gateway. So if you had a need to do something after the gateway started, if you wanted to copy something somewhere, you wanted to move a file across, you wanted to do some regular expression on a file, you could do all of that as part of a set of scripts here. So the entry point for this is going to be very, very simple. It's just going to go ahead and copy files across, and also run any custom scripts that you want to run. It might be that you want to head out to a repository and download something. So this entry point is going to be very much configurable to whichever sort of need you have in terms of populating the folder that's going to be copied across to the gateway for Bootstrap. So to build this, very simply, we're just going to run docker build -t. If I go to the Docker file, it's just using BusyBox. You can use any image that you'd like. We're setting the work directory to config. And we'll just copy and config into config, and our entry point is just going to be that entry point.sh there. So we'll quickly head into InitContainer, and we'll just run that Docker. Just run it once. So that's built, and we can just push that across to our private registry, and that should now be available in our private registry. So the next part, now that we've configured our init container, is to do some pre-steps that we'll use to do some pre-steps. So we're going to create some things in the Kubernetes namespace that we'll be deploying our gateway to. We're going to use customize to do that, as mentioned. So customization. So this customization.yaml is basically going to create a bunch of resources for us in Kubernetes. So we're going to start with BRCM Labs TLS. That's going to create a secret called BRCM Labs TLS, and we'll use that in our Ingress controller because we're going to be going through an Ingress controller in today's demo. We're then going to create a secret for Harbor, which is what we'll use to access our private registry. We'll create the SSG license, which we have in this folder as well. And we'll also create a secret.env that has things like the JDBC username and password, as well as the SSG admin username and SSG admin or SSG username and password as well. And we'll also create a config override secret. So as I mentioned, if you needed to load a custom file, it could be SSG security, it could be any other file in the gateway. You can mount that to a specific path on the API gateway. So I'll also show you how to go about doing that. So the next thing that we'll do is very simply just apply that to our namespace, and we'll see all of the different things being created as we do that. So for this, we're going to run kubectl apply, very similar to applying a YAML file, but instead of supplying -f for file, we're going to pass in a customized directory, which is this gateway folder, and that has to have a customization.yaml file for customize to pass that. So there we go. We've got the BRCM Labs TLS that's been created. We've got the config override secret, and we've got some additional stuff created that we'll use in the gateway Helm chart. So I'll just quickly close that and head over to back to our steps. So the next thing that we'll want to do is actually go ahead and install the gateway using our Helm command. So let's go into that gateway configuration and take a look at what we're actually doing with that. So for the license, we have accept set to true. By default, this is false, so you have to accept that license implicitly. We have an existing secret name set for this, so we're not passing through set file gateway.license or license.value. Sorry, we're just passing in the existing secret that contains that. We're also passing in an existing secret for our image pool secret for our registry. And we're not passing in any usernames or passwords. We're using the existing SSG secret, and that's the one that we created as part of the customized folder. So really separating the deployment from the configuration. Enabling the bootstrap script on the API gateway, the one that works with this init container, is just a simple configuration setting here. So it's bootstrap.script.enabled. And there's also a cleanup option. So because everything gets written to op-docker custom, if you want to clean up that folder after everything's been moved across to the correct locations on the gateway for Bootstrap or startup, you can do that just by setting this cleanup flag to true. And that's just going to avoid having duplicate files on the Container Gateway's file system. Equally, you can just set this to false if you're not worried about having that folder populated afterwards. So cloud platform. So this is running in GCP at the moment. So it's a GKE environment. So for the init container configuration, so very, very simply, we've got one init container configured here. It is an array, so you can have multiple init containers configured. We are pointing at the image that we just created. that exists in our private registry. And we are adding a volume mount, which is just our config directory, and we're using that shared path, which is updocker custom. We've also got some custom config enabled. As I mentioned, you might have a need to load a specific file to a specific place on the container gateway, and this might not be something that we provide in the Helm chart as a dedicated mount. So you can use custom config to do that. So you can take things like the traffic logger from the traffic logger assertion, and you can mount the properties to a specified path on the API gateway. And equally, we'll do the same for that ssg.security file that we created as well. And you can do this with other things, with sort of any other file that exists on the container gateway, obviously with the exception of if you're doing this with something like a jar file that's greater than a megabyte in size, then you're going to run into a size limit for Kubernetes. So using an InitContainer is going to be the best approach for that. And the other approach that you could use is a custom gateway image, but we would like to try and avoid that as much as we can. So other things we're setting, very simply stuff like cluster hostname. We've got that database enabled. This is running in an external location as well. Some basic configuration. I've left all of this as the default that we have in the current gateway Helm chart. I'm not setting any specific cluster-wide properties, but if I wanted to have additional cluster-wide properties here, maybe I have a deployment flag that I want to add here to say, this is environment A or environment B or sort of dev or pre-prod or prod. I can add additional cluster-wide properties that are always going to be associated with this particular values file. So you can start separating deployments in that context. And then other things that have been around for a while, like system properties, you can update those if you're directed by support, or if you have specific need for specific configuration, you can add those there. The other thing that we've sort of added fairly recently, and as mentioned, is the ability to configure listen ports directly from the gateway Helm chart. So this is really useful. In a container context because it means that you don't have to log into Policy Manager afterwards and configure ports. It also means that you don't get any of the default ports if you configure this. So by default, if you have this set to false, then you're going to get 8443, 9443, 8080, and 2124, which is the standard set of ports for the API gateway. So with this allows you to limit the access that you get out of the box with the default listen ports. So you can see here I've got 8443, and I'm limiting the management features to publish service message input. I'm also adding a property to this, which is just server Layer7. So when I get a response from this gateway, the server head is going to be Layer7. It's important to note that if you already have a database, so a gateway database, and you enable this, all this will do is override existing configuration. So if there were ports that you wanted to remove or disable that you're no longer using, then you would need to do so either using RESTman or through Policy Manager. But if this is a fresh database, then and this is enabled, then only these ports are going to be created. So you can also do things like enabling TLS. You can also select the private key that you want to use. That'll be the alias of a private key. You can select TLS versions and the cipher suites that you want to enable, for that particular port. And similarly for 9443, you can do the same, except for 9443, we probably want to have some additional administrative access so we can sign into Policy Manager. And that's something that we'll do later on after deploying this. So in this deployment, I've only got 8443 and 9443. I'm not exposing any additional ports because those won't be required for this use case. But if they were for yours, then just setting an additional item here as an array, you'd be able to add an additional port. Equally, if you wanted to bootstrap a set of port configuration, all this translates to is a RESTman bundle. So you'd be able to take that as an example and create your own bundle that you may want to bootstrap directly to the gateway without configuring things in this sort of manner. So the service that we have, this is the primary service or the gateway traffic service. You can see we've only got port 8443 defined here. And we've got the management service, so management.service, and we're exposing that as type load balancer. So this might be something that you define as an internal load balancer. This is the example for GKE. There would be a different annotation that you would add for different environments. This is going to be a public address for this example today. So we'll see a public IP and we'll connect into it. And for that, we're just adding the management ports. Again, if you had additional management ports that you wanted to add, you would define them up here or through a bundle, and you would expose them through configuration here. Ingress configuration. So we have a central Nginx Ingress controller running in this cluster, in this Kubernetes cluster. We're just simply adding one annotation for that, and we're passing through the host that we want to be able to access the gateway via. We're using the secret name that we created as part of our gateway resources, and we're specifying the HTTP port, the HTTPS port on the gateway. So you can either go port name or port number, but we're just using name in this context. We also have auto scaling enabled in this demo today. So the minimum replicas for the auto scaling group is going to be 2. Initially, we'll have 1 replica, and as soon as the auto scaling resource is up and running, then we'll see an additional gateway coming into that. We're going to be using CPU to do this. So we're targeting an average utilization of 60. And we've also got, via the auto scaling v2 API, we've got scale up and scale down behavior. So it won't scale down until it's been below 60% for 5 minutes. And we'll scale down 1 gateway every 60 seconds and scale up. We'll scale up every 15 seconds. We'll scale up every 15 seconds if the average utilization goes above the threshold that we set. So some of the existing bundle functionality that has existed in the gateway for a while, I just thought I'd quickly touch on that. So if you have bundles that exist in Kubernetes as config maps or secrets, so if you had bundles that you created as part of the customized folder, you can reference those here as config maps or secrets. With the so that's definitely possible, and those are going to work very similarly as things that'll get bootstrapped to the gateway. One of the limitations on this in terms of Kubernetes, though, is the fact that config maps and secrets have a size limit of 1 megabyte. So you're going to quickly run into problems if you have very large bundles, which is where using an InitContainer is going to be a better bet. There is option to use the Kubernetes secret store CSI driver. Some key value stores do support file sizes bigger than a megabyte. An example of that would be something like HashiCorp Vault. I'd imagine that AWS, Azure, and Google have similar, or GCP have similar options available as well. But a more simple way to do that would just be maintaining that with an InitContainer. You can have that stored in Git, so it makes it a bit easier to track exactly what changes between different versions and so on as well. So before I go ahead and install the gateway, are there any questions on the configuration that I've just gone through? Okay, so the next thing that we'll do is very simply just install the gateway Helm chart. So in this context, we're running Helm upgrade -i. The -i flag is basically shorthand for install. So if the release SSG doesn't exist, then it's going to create it. So SSG is our release name there, and we're passing in the gateway's value, the gateway values.yaml that we just defined or that we just looked at. Layer7 is the repository, the Helm repository, and gateway is the chart. So that's now been deployed. The first thing that will happen is our InitContainer will start up. It'll run to completion, and then the gateway will start after that. We've got some sort of useful messages about what we've configured. So we can grab the gateway services by running this command here. So we can see that we've got the SSG gateway. So SSG gateway of type cluster IP, and that's listening on 8443. And we've also got the And we've also got the SSG Gateway Management Service, which is a load balancer with an IP address that's pending. That'll come through shortly. And that's listening on 9443. So the next thing that we can do is get pods. So we can see we've got two gateways that are coming up. We've got our PM tagger as well. That's running. So neither of those gateways are ready. But when those are ready, we'll take a look at them. So PM tagger in the background has selected a pod as the management pod. It's just this one here, and what it's doing is waiting for it to be ready to sort of start accepting connections. And we can see both of them, or one of them at least, is up and running now. So we should be able to start accessing the gateway now. So the next thing I want to do is just show you the logs from one of the container gateways. So for that, we'll just do kubectl logs, and we'll pass in one of the pods. Because we have an init container and the main container, we have to specify which one we want to access. If I don't specify gateway, then it's going to ask me which one I want to use, because there's gateway and gateway init. So I'll specify gateway there, and that's going to go into a file called gatewaylogs.txt. And I can see from the top here, the gateway started up. As part of the Bootstrap process, we're running this custom script here, which is going to be looking in the updocker, so in the updocker folder, in the updocker custom folder. The first thing it does is scan for bundles. So you can see it found the hello world.bundle and it wrote it to the Bootstrap directory. It then scanned for custom assertions, found the traffic logger sample custom assertion and wrote it to the correct location. It did the same for modular assertions with the gateway GraphQL assertion. And it also executed the script that we had in that folder. So that did something really important. Because we had cleanup equal to true, updocker custom was removed after the script ran. So now that both gateways are up and running, we should be able to access the gateway on this endpoint. So this endpoint is going to route to the gateway that PM tagger has tagged for us. And even though we have two gateways, we should get a stable connection back in through Policy Manager. So very simple password, just admin 7 layer for this example. And you can see with this example here, we've gone on to the gateway on port 9443. This is also listening on an Ingress endpoint that we configured. So we'll access this Hello World server shortly. But we can see we've got Hello World there. That's the bundle that we configured on any container. We've also got the traffic logger custom assertion that we loaded in. And if we wanted to as well, we could also go through and publish internal service, and we can specify Graphman, which is the modular assertion that we loaded in. So very, very quick and simple to sort of load those in. And something that's going to be repeatable across different gateways. So you're always making sure that you've got the same configuration across all of your gateways before you connect to the external database, or if you're running ephemerally, just on the gateway's file system. So as part of that last step, we'll just do a curl to this hello world endpoint. And we get a message back, which is just hello world from our very, very simple service there. And I can also see here, I can do the same from a browser. We haven't configured any keys in the gateway. We configured keys on the Ingress resource. So that's being terminated before it gets to the gateway. So with that, I've showed you some kind of more advanced gateway Helm chart use cases or uses. And we've just gone through configuring the init container. We've gone through configuring additional resources, additional files for the API gateway, and connecting through Policy Manager to a gateway deployment that has more than one replica running in it. So thanks. Are there any questions? Are there any questions that aren't related to this and maybe related to something else?
Just blown everyone away, Gary. We'll give people a chance to come off mute because I think Bill muted everybody. So if you are talking and you're on mute, come off. Oh, is this?
Yeah, Gary's too good. It's hard to keep up with him, isn't it?
There are some questions in the chat, Gary, but I think you might have answered those as you went along. Is this 2 cluster or 2 nodes in 1 cluster?
So this is a single gateway deployment. I'm guessing by cluster you're referring the question is referring to gateway cluster, right?
Yeah, that question was at 9:14, so I think it's when you were showing your slides.
Okay. Yeah, so the initial demo that may reference or the slide that may reference is this over here. Yeah, so this is 2 separate gateway clusters. For the demonstration, we just went through configuring one of them.
Okay, so in that case, why would you need a a pod tagger if it was a cluster of 1 gateway?
So if it's a cluster of 1 gateway, then having something like PM tag or the management service is useful in the context of not having access from the outside world. If you're looking at the ephemeral use case, then having PM tag or having a management service at all is sort of less useful because there's no clustering between gateways. So if you connect into Policy Manager on an ephemeral gateway 1 and make a change, it's not going to apply to ephemeral gateway 2. But definitely when you have a database-backed gateway and you have access to Policy Manager, or you want to use Policy Manager, and you may want to scale that cluster in the future, having a secure way to access it is really important.
Okay, understood. Thank you.
There was another question, Gary, which cloud platform is this demo working? Is this demo running in? I think you answered that. You were using GCP today, right?
Yeah, that's right.
Yeah. There's a few people saying fantastic demo, which is nice.
I'm just trying to get the questions. Yeah, sure.
So a couple of questions. In your demo, I didn't see any database deployments and yada yada. All, related to the database because that's most what we deal right now, like with our deployment. My second question is maybe I don't know if it's too early to ask, but the encapsulated assertions and technical assertions, how do we get some kind of a how do we deploy that with the container?
Yeah, so I'll answer those in order. So this gateway deployment does have an external database that's running in GCP as well. I'll go into the configuration of that. So that was configured as part of gateway resources. So we didn't configure any usernames or passwords here because you don't necessarily want to have your database username and password in a plain text values file, right? So that's actually configured here. So this might be done as part of a separate separate system or process. So you can see that I've got a database user and I've got a database password, and I've got stuff there like my cluster password as well. So that's all configuration that gets added into the gateway values. And then from a database perspective, I've got database enabled as true. Creates is false. So if create was true, then what would happen is the MySQL subchart would be deployed. But we don't want to do that for anything other than a really quick development environment. And we've got the JDBC URL configured there with the database. So that's all we need to configure to connect to that external database. And the second question related to encapsulated assertions. So encapsulated assertions can also form part of bundles. So you could include that as part of an InitContainer. So you could have some encapsulated assertion.bundle, which may include the encapsulated assertion along with some additional resources. So equally, you could maintain that using the GMU or RESTman directly. and you would have a way to sort of access RESTman on this gateway. So you could do a post directly, or a post or a put directly to the gateway via a CI/CD pipeline that you may have, to sort of update the gateway while it's running with additional encapsulated assertions, or just additional configuration that you want to add. I also mentioned GraphMan. So GraphMan is not live yet. This will be in the future a much easier way to move configuration between gateways in a much more simplistic format versus RESTman.
Hey, Gary, you've reminded me, actually, we were going to give a shout out, if I can find the link quickly, or if Francois on the call and has the link quickly.
It's already in chat. I was actually just about to segue into Gary mentioned GraphMan, and as Aaron just pointed out, we did want to give a shout out. So in the chat window, you'll find a link to a video that Francois, our CTO, we actually just published it yesterday. If you're not familiar with GraphMan, it's a new configuration tool for Layer 7, and it's representing the configuration in just a cleaner format, and it's better suited for configuration in code. So what Francois wanted to do is, as Gary said, it's not quite ready for prime time, although it's close, is he wanted to show how you install it, how do you do basic configuration, bundling, manipulation and configuration, and also a really high-end overview. So with that, I'll turn it back over to Aaron.
Yeah, no, that's what I was going to say. If anybody watches that video, they're interested in, getting early access to GraphMan, or have any questions or feedback on that, please get in contact with us. We'd love to hear that. Like Bill says, GraphMan is being worked on now.
So there's also a question from Remco. For the appliance, you'll need to upgrade the database and SSG config menu. If you're using a database with a container gateway, how does this work after using a new image for a gateway version upgrade? So very good question. That's actually the second time I've had this question this week. So upgrading from something like Gateway 10 to 10.1, and we had someone in the field validate this as well this week. So let's say you're running, so container gateway 10.0, and you want to go to 10.1. Just by selecting the 10.1 image tag, the gateway will start up, and it will update the database. In terms of backwards compatibility, you can also go back from 10.1 to 10.0. I guess there are ways to make sure that you don't have a situation where you have 10.0 and 10.1 running at the same time. That would basically be, let's say you've got a cluster size of 3. You would set the burst, the rolling upgrade, the rolling upgrade burst setting to 3, and max unavailable to 0. So you would have that match to the sort of size of the cluster that you're running. There shouldn't be any problem running 10.1 along 10.1 along 10.0. We always recommend, if you are if you are going through an upgrade like that, not every gateway is configured in the same way. Although it should work, it's always better to do it in a dev environment, make sure everything works as you expect it to, and then move to updates in production environments. But yeah, there's no need to go into an SSG config menu and go forward with an upgrade in that method. It should happen automatically when you update the image tag and deploy the new version of the gateway. So there's a question here about links to the recordings of the previous sessions. I know that we have a playlist on the YouTube channel Broadcom Infrastructure Software. Bill, is there a link that has is there a link that we can share?
It's either that, Gary, or if you go into community.broadcom.com and join the Layer7 API management community, you can find them in there pretty easy. Just search for office hours.
Yeah, thanks, Aaron. I clearly haven't learned how to turn mute off yet, but yeah, that's exactly what I say. It's on that channel on YouTube, the Layer 7 channel under Broadcom, and all of them are available on communities. That's first thing. In fact, tomorrow, normally I do it this afternoon, but tomorrow, first thing, I'll be posting it up on communities with a link back to the Layer 7 channel on YouTube.
So there was just a question about the the demo being in GitHub. So yes, if I can make that smaller. So yes, the majority of the example that I went through today is currently in GitHub. So if you go to the Gateway Helm chart, there's a breakdown of so some recommendation, what's been updated in the latest versions, and there's also the InitContainer examples that you can access there, along with additional examples of how to configure any additional stuff that you might want to. So the InitContainer example is part of the Layer7 community utilities repository. And in that, there's a simple example and a dynamic example. It's basically different base images and different files, different types of files that you can load, like keys and so on, in this dynamic example, and then different ways to install them. So just download or clone the repository, CD into this gateway InitContainer folder, and then just run make install simple or make install dynamic, or you can run the commands sort of manually. So it makes sense to use a local development environment to do this. It could also be so making use of so either a local environment or a dev environment to try this out. The images that I've referenced today aren't actually available. So the InitContainers aren't available publicly, but the ones here are. So like this one here, I think is so there's two. Yeah, so if you go through the example, there's two InitContainers that are available. They're available on the Layer7 API Docker Hub repository. The best way to use this demo, though, is to add your own configuration to the config folders, and then create and publish your own Docker images, and then use those to move stuff onto your gateways. As you start moving towards production scenarios, that would be the it would be a good time to look at if you have a private registry at the moment, and sort of what the process is about publishing those containers to various sources. So there's some more questions coming through in chat, so I just want to open this up. For custom tactical assertions. Yeah, so for custom tactical assertions, those would either be in .aar or .jar format, and those would just be loaded into the corresponding folder when you build your InitContainer. So there's a place for custom assertions, which is .jar, and then modular assertions, which is .aar. So you just place those in the correct folders, and then when the InitContainer runs up, it'll move everything to that Docker custom folder, and then the gateway will pick that up with its Bootstrap script, provided that that's enabled, which is just some configuration over here. So just enable that, pass in the configuration with the correct mount path. Have your InitContainer location, and everything should be moved to the correct place and taken care of. Okay, so there's a question here about SSL keys. So this is actually one of the use cases for the dynamic assertion. So we actually have an internal team that found a way. So first off, it'll be a lot simpler when Grafman is enabled. Grafman has much better key management capabilities that will be sort of brought in. For the time being, there's a couple of ways that you can have keys sort of rotated, and so different keys available on the container gateway. So in this configuration here, you can see I've got my port configuration. So I can change the default SSL key from something to a different alias that exists on my container gateway. So so your keys can either be made available to the container gateway using a bundle. Bundles that contain keys have to be encrypted in a gateway readable format, and that's going to be decrypted using your cluster passphrase. So what we have in the dynamic example is a PKI folder. There's some default values here. So there's a gateway 1 brcmlabs.p12 and another one there. And then there's a couple of scripts that run to put those into the correct format. So these run as part of the init container. So this will look at the PKIF folder, and it'll basically convert those into something that the gateway understands, and then it'll then copy them to the updocker custom folder. So this is one potential option that you could look at for having different keys loaded onto the gateway. I wouldn't recommend overriding the default SSL key. You can set it when the gateway starts up with SSG SSL key and SSG SSL pass. But it's better to use a different key, because if you override that, which you can do from the method that I've just mentioned, it doesn't get updated immediately. You have to do a gateway restart, which is not optimal from a container perspective. So by specifying a different alias here for the port that you want to change, that can be the key can be created as part of the bootstrap process, and then when the port starts up, it'll start serving the correct key. Equally, in the future, if you change the key, you can change the key through through RESTman while the gateway's running. And obviously, from a container gateway perspective, from an ephemeral gateway perspective, changing the key might require that the gateway restarts. At least now it would, although that may change in the future.
A good question, because if you change it via RESTman or Grafman, the gateway still needs to be restarted, right, before it takes effect, if you change the key.
So from RESTman, it technically shouldn't need to be restarted. So what should happen in the background is the port itself gets restarted, which is the reason that you can't modify a port that you're connected to if you're in Policy Manager. So if you're connected to 443, you can't. Yeah, so that should technically happen. But yeah, in terms of the gateway starting up and so on, with the correct key, with the correct configuration, setting the private key here is something that's quite useful for that. Just sort of bear in mind that the default SSL key doesn't change. So if you're doing a route via HTTPS and you're using a private key for mutual TLS to a downstream system, it's always going to default to using that default SSL key unless you explicitly set the key that you want to use. So that's something to bear in mind for when using that with the route via assertions. Different SSL keys with the same alias. So I'm guessing that's the same alias but different keys, right? And you wouldn't necessarily have the So I think you'll be
correct.
Yeah.
Different keys, same alias. So
Yeah.
when you go from one environment to another environment, it still uses the same alias, but use a different key.
Yeah, so I guess what you could do there, and that would be down to the way that you configure your sort of init containers. You might have keys in different locations, right? So that might be having a different init container. So you might be building from a different you might be building a Docker image from a different branch. Maybe it connects out to a key store somewhere as part of your build process. It pulls that key down and you create the Docker image for your dev environment or for your prod environments and so on. So yeah, you could do that with config. You could also have for keys and so on, you could have that in config maps or secrets in your Kubernetes environment. So you could create the key with the same alias. You could create that as a secret, and then you could just reference that secret, and that secret's going to be different per namespace or per Kubernetes cluster, whichever way you separate those environments.
Okay, thanks.
So I can't see any questions that we haven't touched on in the chat. Are there any additional questions?
Additionally, you want to bring up, Aaron?
No, just a reminder that we missed December for the office hours, but we will, of course, be doing this every month. We have a plan for next month's topic, but if there are other topics people want to suggest, feel free to do that either on the community or directly to any of the Broadcom contacts. We're always interested in getting topics from other people. But other than that, I just wanted a big thanks to Gary because that session was awesome. Really good, Gary.
Yeah, thank you, Gary.
Thanks, Aaron.
And as I said earlier, this session will be available, or this recording will be available tomorrow morning up on communities. And the next office hours is February 19th. We look forward to seeing you there. Thank you very much and have a great rest of your week.